Alright, so this video is going to be about the curve sketching part 2 in your notes. This is on page 13. With these one, you'll notice in the last video we did curve sketching and we had those radical equations where there was a fraction going on, which gave us those horizontal and vertical asymptotes to help us get an idea of what these graphs look like. With these polynomials, we won't have that because there's nothing being divided, there's not going to be any asymptotes. So all we're going to be looking for in these ones are those zeros. So what I'm going to do is I'm going to just take this equation and say, hey, we're setting this equal to 0. So just like when we solved earlier, we're going to factor. So factoring here, we're saying, hey, what multiplies to a 1 times negative 2, so a negative 2, but adds to a negative 1, well, it's going to be a negative 2 and a 1. So our factors here are an x minus 2 times that x plus 1 equals 0. Take each of those factors, set them equal to 0, x minus 2 equals 0, x plus 1 equals 0, so we have our two zeros here, x equals a positive 2, and x is equal to a negative 1. So what we're going to do is just over to the right, we're going to do a really just rough sketch of this. We don't need as many details as we did with our last ones, because we just want an idea of what the shape of this graph looks like. So I'm just going to plot some x values here. So we know we have zeros, or y value is 0 at x equals 2 and at x equals negative 1. Now I just need to think about the shape of my graph. So what I'm going to do is I'm going to say, hey, but this is an x squared function, and that leading coefficient in front of it is positive. So my parent function, y equals x squared, well, that's the graph. That is just our regular parabola. So that means our graph is going to look like that as well. One other point I can find to help us graph this is that y-intercept. So we're going to say, hey, when x is equal to 0, what is y equal to? Well, it's going to be a 0 minus 2, so y equals negative 2. So over here, 1, 2, we also know it must go through this point here. It's going to have this shape. So from each of these points, because it's going up, that means it will be going up from each of these as well. But they need to go through this point down here, so it's going to come down and look something like so. That is all we need for this. We're not looking for any more points than that. For the second question, with this one, we need to first recognize, hey, that these both have an x in it. So we need to factor that out before we move forward. So we're going to say, okay, we have a y is equal to, and I'm also going to take out that negative, because whenever I see a negative, I don't like a leading coefficient that's negative, so it's going to look like, okay, a negative x times x squared minus 1. So when I pull that negative out, it switches the sign on both of those. Once we're here, okay, once again, we see this x squared minus 1. Hopefully by now we're recognizing that this is that difference of squares, x minus 1 and x plus 1. So remember, we're going to be setting these equal to 0 to solve it. So 0 is going to be equal to a negative x times an x plus 1 times an x minus 1. That means we're going to have 3 zeros here. When we see that x cubed, we should think, hey, can have 3 zeros, 2 or 1. But at a maximum 3, and we have all 3 of them. What I'm going to do, take each of those, set them equal to 0, negative x equals 0, x plus 1 equals 0, and x minus 1 equals 0. So x equals 0, x equals a negative 1, and x equals 1. So normally we would say, okay, next find that y-intercept. Well, x equals 0 is already here, which means if I plug 0 in, it's going to be that origin, because we'll get another 0 back out. So a 0, 0. Okay, so if I go to plot this, we know the point negative 1, 0, and 1. Now we need to think about that parent function again. Well, this is a cubic, but it has a negative leading coefficient here. So normally we would say, okay, well, y equals x cubed. That's the graph. It looks like this. But we have that negative in front, so we need to reflect it. So we're really saying, hey, our parent function is a negative x cubed. So it's going to be the graph that comes down and goes like so. Because we have more than just this 1, 0, our graph is going to look a little bit curvier though instead. So what it's actually going to do, so it needs to go up from here, needs to go down from here. But instead of just like a straight line connecting it, it's going to be like, okay, well, I'm going to come down, go back up, and then come back down. So there's some rules from Algebra 1 that would help us get an idea of whether these cross or bounce up and go away. And we'll talk about that in just a second when we talk about this next problem here, and then we'll come back and explain why those cross there. So for the quartic function we have here, we may see this x to the fourth and panic. Don't, because we also should see this x squared here and say, oh, I can take an x squared out of each of these. So really we're going to have y is equal to an x squared times x squared minus 2x plus 1. Now we're going to be setting this equal to 0 again, trying to solve it using our factoring. So we have an x squared times, well, we're saying, hey, what multiplies? Because I have 1 and 1 to a positive 1, but adds to a negative 2. It's going to be a negative 1 times a negative 1. So, box here, so that means I have the same factor as x minus 1 times an x minus 1 equals 0. So really we're saying, okay, well, I have that x squared equal to 0, so I have x equals 0, but that's occurring twice because I have two x's out in the front. For this x minus 1, well, we're finding x equals a positive 1, but that's also occurring twice. So when I draw my graph, what actually is going to happen is at this 0 and at 1, I have a quartic function. Oh, oops, sorry, got to switch colors. Y equals x to the fourth. That's going to look very similar to a parabola, because right now it only has 1, 0. This one has 2, so it's going to be curvier again, just like what happened here, but it's going to look different. These both need to be going up from here, because it's quartic, it's positive, it's going to look like this function. But we have two choices. We could say, okay, it's a parabola, it scoops down here, so our potential is it comes down this way, or we could say, well, what if it went like this? And the way we decide is by looking at these two. Because this x equals 0 occurred 2 times, it actually bounces off. Because this one occurred 2 times, this bounces off. It makes that W shape. So one way to help remember this is because these are squared. When they're squared, they act like parabolas at that point. So for this one, at x equals 1, it acts like a parabola. That y equals x squared. Because it was from a squared function, I could have rewritten this as x minus 1 squared. So at each of these points near it, it behaves similar to the x squared function. So up here, each of these only occurred 1 time. That makes it like a linear function. So near this 0, it's going to act like a linear function. It's going to cross through instead. Another way to remember this, if you prefer, if it occurs an odd number of times, it crosses. If it occurs an even number of times, it bounces. So odd was up here, even was down here. So that is the last of our examples here. One thing to look out for if you're stuck on finding that parent function, because it's something where it's already factored for you, so like say you have like a y equals x plus 1 times a 2x squared minus 3. Well, what you would do is you would just say, well, if I expanded this, I would be at an x cubed. That's going to be my parent function for this, y equals x cubed. So you're basically just counting the number of x's you have there. So x cubed, 3x's. Feel free to contact me if you have questions. Go on the class website, you can submit a little email thing to me, whatever you need. Good luck.